Hello everyone, we'll now see our third tutorial, that is creation of abstract model file. So in CAENexus workflow, analysts they are going to create an abstract model file and we call that role as the authoring role. So the first step in authoring role is to create the classes. Now why we need classes? Maybe I'll quickly add some more details here. So in traditional workflow, analysts they are making use of geometry or they are making use of mesh to set up the physics. So for example, in traditional method, if analyst has to apply a load related physics, then they are either selecting some portion of geometry or they are selecting some mesh elements or node to set up that physics. But in CAENexus workflow, if you need to set up the same physics, then analysts they'll have to use the classes and through attribute they can set up the physics. So this is the major difference between CAENexus workflow and the traditional workflow. So the first step is to create classes in CAENexus. So let's see how to create the classes in CAENexus. So once you launch CAENexus, then this is the user interface you can see. Again, we have talked about this user interface a bit in our earlier tutorial. So now we'll see how to create classes in CAENexus. So again, there are two ways by which one can create classes here. So first is you can create it manually, and second is you can directly import the classes from CAD geometry. So that second way we have already seen in last tutorial. So this time we will see how to create classes manually in CAENexus. Now to create classes, one need to go here in this class icon, then go to create, and you can see one can create a class of volume type or surface type, curve type or the point type. So I'll just click here on the volume and I'll give some name here, maybe contact, and I'll click on OK. So you can see here that contact class is added in this window. So I've already talked about why we need class, because in CAENexus workflow, analysts they are making use of these classes to set up the physics. But what exactly the class is? So if you see here, the class, that entity is not having any specific shape. So we are not sure about how exactly this class looks like. But we know that this class belongs to volume type. That is, its dimension is 3D. So classes basically are the entities which does not have any specific shape but has some kind of dimension. So likewise, you can create class of any type like volume type or surface type or curve type. That is, you can create 3D class, 2D class, 1D class or 0D class based on your requirement. I'll quickly show you one more class. I'll again go in the class icon, create volume. I'll just type name as solid and I'll click OK. So this way I've created a solid class which is having a 3D dimension. Similarly, one can create a 2D class also. I'll click here on surface. I'll give name as fix underscore 2D. I'll click OK. So you can see now this fix 2D, it is added under the 2D surface hierarchy. So this way one can keep on creating the classes manually based on the requirement. You can see here now I have created the classes manually here. Again, as I said, there are two ways to create the classes. One is the manual way, which I have shown you, and second is you can import the classes directly from the CAD geometry, which we have seen in the last tutorial. So it is recommended to use the classes or import the classes directly from the CAD geometry, because that will save analyst time, and analyst can directly use those classes in the abstract model file. Let's now see how to create relation. So relation is needed when one is interested in the common entities of two classes. So for relation, two classes are necessary. So I'll select two classes here. One is contact, one is pin contact. So for selecting, you need to press Ctrl here. After that, you need to go here in class relation icon, click on create and just select with classes. So you can see here a relation between contact and pin contact class is created. Similarly, I'll quickly show you one more relation between load and solid. So select these two classes, click on class relation icon, click on create and with classes. So you can see here a relation between load class and solid class is created here. Now here the dimension of this relation is 2D. So the attributes which are supported on 2D dimension, those can be specified on this relation. Also, if one is interested in the relation of class with itself, then you can do that. For example, I'll just click here solid. I'll click on class relation icon, create with classes. So you can see here a relation between solid and solid class is created. So this is how one can create a relation between one volume class and another volume class. Let's now create Ri type of relation. So I'll select two classes here, steel 1430 and steel 2340. Then I'll go here in the class relation. I'll click on create and I'll click here with classes for Ri. So you can see here now this Ri type of relation is created between two volume classes. Now what is the difference between Ri type of relation and the R relation? So Ri type of relation, it does not have a dimension, whereas R type of relation, it has 2D dimension. So one cannot directly specify attribute on Ri type of relation because it is not having any dimension, but you can specify the attribute on its child entities, because the child entities like unpruned and pruned, it has some 2D, 1D and 0D dimensions. Let's now create a relation between volume class and surface class. So I'll just select here solid, that is a volume class, and fixed 2D, that is a surface class. I'll go in class relation, I'll click on create and I'll click here with classes. So you can see here a relation between volume class and surface class is created. Now the common entity between these two would be a size of face. So here solid is a volume class and fixed 2D is a surface class. So the common entity would be a side of face facing towards solid side, that is facing towards your volume class. So this way one can create the relations based on the requirement. Now we'll see how to create the attributes. So as I said, in CAENexus workflow, the analysts, they are going to make use of these classes and they are going to set up a physics through attributes. So this center window is the attribute window, and you can see there are four tabs here. One is meshing, solution strategy, problem definition and output. So meshing related attribute will come here. Attributes related to solution strategy, that is what is like what kind of analysis you want, so those details will come here. Under problem definition, the attributes related to your loading, your constraining, details related to contact pair, so those attributes will come here. And in output tab there would be attributes which will decide what kind of output you want, maybe stresses, strain, displacement, so those details will come here. We'll see how to create an attribute. So let's say I want to create one meshing related attribute. Then I'll go in this meshing tab. I'll select the class based on the requirement. So I'll select size class because I know that I have to use this class to set up the mesh size. So I'll just select that. Then I'll click on create. I'll just select here mesh size. You have the options of relative or absolute. That is, you can specify the mesh size either in a relative way or in absolute way. I'll just select absolute here. So you can see that attribute editor it has opened. So you can give the naming as per your standard practice, and you can specify the mesh size here. Maybe I'll just type 10 here. That is, I want to specify 10 mesh size. You can see here at the bottom there is a model association and it shows size class here. It means whatever we are defining here, it will get transferred onto this size class. So once done, you have to just click on apply and close, and you can see here a mesh size attribute will be shown in this attribute window. Again, if you want to edit it, then you can double click on that and the attribute editor will get open. So this way one can keep on creating the attributes related to all the four tabs. So this way one can create the classes, one can create the relation, and one can create the attribute based on your problem statement. So this role of analyst, we call it as a authoring role, and analysts they have to create this file which is the abstract model file. Now one can delete the attribute, classes and relation based on requirement. For example, if I want to delete this attribute, I'll just right click on it and I'll just click on delete. So this way I have deleted the attribute. In similar way, one can delete the classes also. For example, if I want to delete the solid class, then I'll just right click on it and I'll click on delete. But when I delete the solid class, then relevant relation will also get deleted. For example, just see this solid relation. So once I delete this class, those relations will also get deleted. So this is how one can create an abstract model file. So analysts, they have to create the classes, relation, and the attributes. And this role of analyst, we call it as authoring role. So that's all from this tutorial. I thanks everyone, and if you have any queries, then please feel free to contact at support@novusnexus.com and we'll get back to you accordingly. So we'll see you in next tutorial where we will see some more details related to meshing attribute. Till then, have a good day and bye.